Okay, so for part 2 of homework 1-4, we just have question 9 to wrap up. In question 9, I tried to make sure I had a whole part for this because it is a larger question. And in fact, this one looks a lot like the question you guys had on your quiz, so hopefully you felt comfortable approaching it, but maybe you still need some help. Anyway, part A, if you want to just check and see if you did it right, the total time that it took her to run the race initially, the total time should have been about 12.06 seconds. Okay, so 12.1, 12.06. For part B, for how long, I was interpreting that as the time. How long does it take her to run, to accelerate, if she wants to finish it? The time that she would need to accelerate would be 3.49 seconds. So obviously, if you took that to be distances, you could take that and plug that in as well. But if you got 3.49, well done, well done. So anyway, let's look at how we actually solve this if you need it. If not, congratulations, you are done with this homework. But anyway, so for part A, it's a pretty standard, just kind of work it up in two different parts, right? She accelerates for a period of time, and then she moves at a constant velocity for a period of time. But you really don't even have to do a system of equations because they give you enough information. We know she starts the race at rest. She has an acceleration of 3.35, and she does so for a period of 2.80 seconds. And since they give us that information, we can really find our final velocity by just taking the acceleration, because it's the initial velocity, which is 0, plus the plus the acceleration times the time, excuse me. So I can find my final velocity, which I get to be about 9.38 meters per second. And then I also need to figure out how far she goes while she's accelerating, so I know how much of the 100 meters she ran it while she was accelerating, and then how much she ran at the constant velocity. So then just finding that, basically, again, same thing. So I got v sub 0 t plus 1/2 at squared. And then at this point, I know the 1/2, I have the acceleration and the time. So I just plug those numbers in. I plug in my 3.35. I plug in my 2.8 and square it. And I get that to be about 13.1. So she accelerated for 13.1 of the 100 meters, which then tells me for the constant velocity, right? I know constant velocity, the only equation I'm ever using is v equals delta x over t. The constant velocity is the same as her final velocity, so 9.38 meters per second. She goes a distance of 100 minus the 13.1, so 86.9, and then the time that she takes is what we're looking for, right? So we can solve for that time that it takes her to run that portion. So it's a pretty easy, right? Just multiply both sides by t and then divide both sides by 9.38. So my time then is, for that portion, 9.26. So it took her 9.26 seconds to finish the race, but it took her 2.8 seconds to reach that final velocity. So then that's where I got the total time to be 12.06. So hopefully part A wasn't too difficult. Right, part A, again, not even a system of equations, it's truly just one where you have to set up all the pieces and hopefully just work careful with your calculations. Part B is where it gets a little bit more exciting, right? And the reason for that is all of the times and final velocities and everything like that goes out the window. The only thing that we know is the same is the total distance of the race is still 100 meters, and her acceleration, the maximum acceleration that she can reach is 3.35. Okay, those are the only variables that we really know are the same other than her starting velocity as well. But we can still break this up into the two phases and then try to represent everything in terms of the same variables. So for the acceleration phase, again, I know her initial velocity is 0. Her acceleration is 3.35. I do not know the time that she spent accelerating, but I do know the total time she spent was 10.3 seconds, or that's the time she's aiming for. So I'll go ahead and list that up here, but I don't know that first time, so I'm just going to call it T1. I also don't know the first distance she went or her final velocity, but I'm going to represent her final velocity in terms of these measurements. So her final velocity would be v sub 0 plus at. Well, v sub 0 is just 0, so it would really be plus at, right? So in this case, it would be 3.35 T1. So I'm able to represent her velocity in terms of T1 as well. So I actually don't have a new variable, I just have the same variable used in a different way. Similarly, for the position that she goes, I know it would be v0t plus 1/2 at squared. Well, since I know her acceleration and her initial velocity was still 0, I know it would be 1/2 of that, so 1.675 t1 squared. So at this point, even though I have several unknowns, I can represent them all in terms of t1, which is obviously very helpful. I've got everything represented in terms of t1. So then if I jump over to the constant velocity, well, again, the only equation I'm working with is change in displacement over t. I know her constant velocity is 3.35 t1 because that was the final velocity she reached in terms of t1. I know the displacement that she goes is going to be 100 minus however far she went for this first displacement. Okay, so I'll call x1 for right now, but we'll substitute this in just a second. Similarly, I know her time is going to be the 10.3 minus t1. So the key here is I can take everything and plug in everything in terms of t1. And hopefully at this point you can obviously see where we're going. So maybe at this point, if you want to stop the video and just finish it out on your own, you're more than welcome to. But anyway, I get something that looks more or less like this, to where my only variable is now t1. So obviously we do just have to solve this now. We've got to multiply both sides by the denominator. When I do that, I get 34.505 t1, that's coming from the 10.3 times that, minus 3.35 t1 squared, equals 100 minus 1.675 t1 squared. And obviously at this point, if you look at it, you've got a t1 squared and a t1, so you have to get everything to the same side so that you can factor it. So then when I get everything to the same side, I get a positive 1.65 t1 squared minus 34.505 t1, and then plus 100. So that's where I get my quadratic formula, that's where I get my quadratic equation from. Right, at this point, just do your quadratic formula, which hopefully we're all very comfortable with. Right, if not, we need to be, but if you do need some practice, let me know. But anyway, we just do our quadratic formula. You get two possible answers. You get t1 either equals 3.49 or t1 equals 17.1. The 17.1 doesn't make any sense because we were trying to run this race in 10.3 seconds, so that is not possible. So instead it has to be the 3.49. Okay, so for this question, I interpreted it as how long would she have to accelerate, being the time. It didn't ask how far she would have to accelerate, but if it did ask how far, you would simply take this time and then plug it back in up here, and then you'd have your displacement pretty easy. So in any case, I hope this helps. This is very similar to the quiz question we saw before. It is a very good question. Make sure you're comfortable working. Right? I know the systems of equations make it pretty difficult, but it's only algebra, right? It's just algebra. There's not even any calc involved. It's just making sure you can set everything up and then manipulating a system of equations. So anyway, that finishes homework 1-4, and we will move on to 1-5 shortly enough.